What if you could interact with applications that are open, trustless, and run without a middleman? What will change in the world? Well, that's a big question, but today we are focusing not on what will happen, but how it could happen with dApps and smart contracts. Hey, I'm Mark from Ryzen, and let's not waste any more time. Smart contracts might sound like a fancy term, but in simple terms, they are just user-defined programs that run on the blockchain. Think of them as the backend of your decentralized application, where all the logic and the flows are happening. So, how do you create a smart contract? Just like building any program, you need to write some code. And the programming language you need to use depends on the blockchain. If you are curious about the programming languages used in Web3 ecosystem, we also got that covered in another video. Now let's go back and explore a smart contract written in Solidity. Let's break it down. At the top of the contract, the Solidity version is specified. This is important because the behavior and the features of the code depends on the version used. And it also helps blockchain nodes to understand how to interpret the code. In Solidity, a contract is just like a class in any other programming language. This contract is named Hello World, and it has a global state called message. The constructor function is special. It only runs once, and that's during deployment. To deploy the contract, you need to provide the message parameter. And this parameter will initialize the global state message. But keep in mind that you cannot call this constructor again. It's strictly one-time setup. The update message function allows anyone to update the state of the contract. However, this function is only accessible if you know the address of the contract. After you write the code, the next step is to deploying it to the blockchain. The deployment requires a special transaction, which transfers the smart contract code to the blockchain. Once the transaction is processed, the smart contract gets its own unique address, just like any crypto wallet. Here is the cool part. Since smart contracts are permissionless, anyone can access and interact with them, if they know the address. Once deployed, they live on the blockchain and remain accessible until the owner decides to shut it down. It's like giving a life to a digital entity, which lives on the blockchain, ready to perform its tasks. Also, in smart contracts, even if someone changes the state, the previous states are always accessible by querying the blockchain with a block height from the past. You can think of block height as a timestamp for transactions. This means you can trace the exact state of a contract at any given time. Keep in mind that this flow applies to smart contracts written in Solidity for blockchains like Ethereum and Polygon. Different blockchains might have different architectures. Now that we understand how smart contracts work, let's have a look at dApps, or decentralized applications. A dApp is an application that runs on the blockchain, meaning it doesn't rely on a single server or authority. Instead, it uses smart contracts to define the logic and the rules. And blockchain takes care of the transparency, immutability, and security parts. The front end of a dApp looks just like any other website. The key difference is it interacts with the blockchain to retrieve data and perform actions through smart contracts. Let's break down how we can create a dApp by connecting it to the smart contract we showed earlier. First, the user needs to connect their crypto wallet, like MetaMask, to the dApp. Once connected, the wallet allows the user to interact with the dApp and sign transactions. Assume that the dApp has an input box, where the user can type a new message. After the user writes a message and clicks on the update button, the dApp will generate a transaction which calls the smart contract. After the transaction is generated, the dApp prompts the wallet for user to sign it. Signing confirms the user's approval with a small gas fee for the transaction, which helps power the network. After signing, the transaction is broadcast to the blockchain. The network nodes process it, and if everything checks out, it's on the blockchain. Once the transaction is confirmed, the new message is now stored in the smart contract. The dApp reflects the update, and that's it. We have successfully created a simple dApp. And you have learned how these concepts work together to create a decentralized system. Whether you are looking to build your own or simply understand how they function, there is so much more to explore. If you are ready to dive deeper into the world of blockchain, we are preparing lots of videos on advanced topics like DeFi and more. See you in the next one. And as always, don't stop. Keep on rising.